the curves, we discuss about that. Sketching the curves, how we find the sketching the graph. So here follow the seven findings. What findings? Suppose f of x is a function, y is equal to f of x. First we find its domain and range. Its domain and range. So how we find the domain and range? Here x value is the domain. X value is the domain. These values are domain. Y values are range. Y values are range. If x values given to here 1, suppose y value another 2 coming. So 1 is belongs to x domain, 2 is belongs to range. So like this we find the domain and range. After this, its intercepts. For intercepts, we put y is equal to 0, then x is equal to some value coming a. Put x is equal to 0, then y is equal to b coming. Then here intercepts a comma 0 is the one intercept, x intercept, that is. X is equal to 0, y is equal to b. This means y intercept. 0 comma b is the y intercept. Suppose any line consider like this. This is the x intercept, this is the y intercept. It is b. Like that, curves also. This is the x-axis. Suppose this is the y-axis. This is the a, this is the b. This is the intercept length. At x is equal to a, at x is equal to b, intercepts having. Next, critical points of the function. Critical points of the function means critical points. How we find the critical points of the curves? So this given function, we do the derivative, first derivative, dy by dx, otherwise f dash x, both are same. If f dash x is equal to 0, then getting x is equal to a or b. These x is equal to a and x is equal to b are the critical points. Critical points. Suppose this is the curve. So x is equal to a. Suppose here x is equal to a. This is the critical point at x is equal to a. And this is also critical point, it is the b. So at b, another critical point having. So these end points, the big points are called critical points. After this, local extrema of the function. Local extrema. Extrema, local minima or local maxima. That means first function, given function, we do the first derivative dy by dx is equal to 0, then x is equal to a and b getting suppose first derivative. Next after that we do the second derivative d square y by dx square. In this d square y by dx, we have some function coming here in terms of x. So in this d square y by dx square at x is equal to a, substituting in this function x is equal to a. Suppose this value is less than 0, second derivative less than 0, then f has maximum at x is equal to a. If it is less than 0, the function having the greater value is here maximum value at x is equal to a. Next d square y by dx square at x is equal to b, suppose it is greater than 0, then f has minimum at x is equal to b. This is the about the local maxima and local minima. So that values, how we find local maxima value how much, local minima value how much. Then these values, these critical points, x is equal to a, f has maximum value. That's why f value, we find the f of a. this value, something value coming, that is the maximum value. Substitute in f, that b, so some value coming, that is the minimum value at x is equal to b value. After this, points of inflection. How to find the points of inflection? So y is equal to f of x function. We do the first derivative f dash x and y double dash f double dash of x. This means y, this is the d square y by dx, dy by dx, this is the d square y by dx square. So f double dash x is equal to put 0, second derivative equating to 0. Then x values, suppose c and t coming. So at x is equal to c, one point of inflection, at x is equal to d, another point of inflection. Okay, where is the sign changed? There is the point of inflection having. So point of inflection, how it is? Suppose like this curve. So here onwards it is positive, here onwards negative. So this is the point of inflection. So here plus, here minus. At this junction, point of inflection is there. So after that, concavity. So in that second derivative, d square y by dx square is greater than 0 at some intervals a to x b. D square y by dx square greater than 0 in between a to b. This concavity upward in this interval, it is the upward. When d square y by dx square greater than 0, the curve upward. If d square y by dx square less than 0, suppose x lies between c and d. So in between these, here less than 0, that's why downward, concavity downward. So upward means like this, downward means like this. That is the concavity in the particular intervals. Example 7.69, page number 50. Sketch the curve y is equal to f of x is equal to x square minus x minus 6 given. So here given function, again we write y is equal to f of x is equal to x square minus x minus 6. This is the given function. So first of all, what we find here? First thing, domain and range. So how we find the domain and range? Suppose in this function x is equal to minus infinity port, then y is equal to also minus infinity, here minus infinity square plus, here minus, here minus. So it is minus infinity coming. X is equal to plus infinity, then y is also going to plus infinity. So x is equal to minus 1, put in this minus 1 square, 1 minus, plus 1 minus 6, minus 4 coming. Now x is equal to 0 taken. So here 0, 0, minus 6 is equal to minus 6 coming. X is equal to 1 put. Then x is equal to 1 minus 6, minus 7 minus, this is cancelled, minus 6 coming. Okay. So here, this is the set A, this is the set B, this is the function f of x. So in this A set, that A set is called domain. All x values belongs to set A, this is the domain. That function related values are codomain. Its codomain equal to range here. How it is equal? So related values, every set of B values related to image of A. That's why it is the codomain is equal to range coming. So x tends to x is equal to minus infinity. It is also minus infinity. X is equal to infinity. it is also infinity. After that minus 1 put, minus 1 related value minus 4, and 0 related minus 6, and 1 related, 1 is the minus 6, this also. So here minus 6 double time coming. Then in this B elements having at least one element in this, that's why it is the function. Here these values are domain, these values are codomain. So minus infinity, infinity, this is the all real values. Here also minus infinity, infinity, all real values. So x belongs to R, y belongs to R. Here x belongs to R, y belongs to R. This is the range, this is the domain. Okay, next this topic is over. After that, the intercept of the curves. First, second one, find the intercepts of the curves. Intercepts. How we find the intercepts? Already I told you. If x is equal to 0, then y is equal to how much? This is the y is equal to f of x. X is equal to put 0 here, 0, 0, minus 6 coming. So y is equal to 0 put. Then x square minus x minus 6, this value is the y, this is equal to 0. So what value is coming here? X square minus 3x plus 2x minus 6 is equal to 0. So minus 3 plus 2 minus x, minus 3 into plus 2 minus 6. So it is x common, x minus 3 plus 2 common, x minus 3 is equal to 0. X plus 2 into x minus 3 is equal to 0, x is equal to minus 2, and x is equal to 3. These values are intercepts. So this meaning point wise minus 2 comma 0 1 intercept, and 3 comma 0 1 intercept, and here minus 6 0 comma minus 6 1 intercepts. So like the curve is like this. Here to minus 2 0 and 3 0, minus 2 0 here, 3 0 here suppose, and 0 minus 6 downward, x y negative, that's why down. This is also y intercept, this is the y intercept, this is the x intercept, this is also x intercept, this is the origin. So the curve passes through these 3 points. The curve passes through these 3 points. That 3 points what? Minus 2 0, 3 0, and 0 comma minus 6. So y intercept is the minus 6, x intercept 3, here minus 2. So minus 2, 3 and minus 6 are the x and y intercepts. After that, critical points of the function. Critical points. So how to do the critical points? How to find them? So given function f of x is equal to this one. So do the first derivative dy by dx. Otherwise f dash x, both are same meaning. So first derivative x square derivative 2x minus x derivative minus 1 minus 6 0. 2x minus 1 is the first derivative. After this, for the critical points, f dash x is equal to 0, should be 0. Then f dash x is the 2x minus 1 is equal to 0, 2x is equal to 1, x is equal to 1 by 2. 1 by 2 is the critical point. At x is equal to 1 by 2, this function having critical point. After that, local extrema of the function. Local extrema. Local extrema. Local extrema means local minima and local maxima. Local extrema means local minima and local maxima. So we find here how to find local minima and local maxima. That means local extrema. Here f dash x is equal to local extrema for this y is equal to f of x, this function. We do the first derivative and second derivative also. So first derivative what coming 2x minus 1. So and f double dash x is equal to 2. So this is the positive. So only this function having minimum value. So here 1 by 2 critical point came up before that. So f dash double dash of 1 by 2 also 2. This is the positive. Yet 1 by 2 f has minimum value. Minimum values means local minima or local minimum value. So we get that value. So for that local minima value, how much? Substitute f of x is equal to x square minus x minus 6. So in this we substitute the 1 by 2. So 1 by 2 whole square minus 1 by 2 minus 6. This value for LCM 1 minus 2 minus 24. So this value how much? 26 minus plus 1 minus 25 by 4. This is the local minima value. Local minima. This is the local minima. Okay. After this, points of inflection. So it is nothing but f dash x is equal to how much? 2x minus 1. F double dash x is equal to 2. So this value is positive. This value only positive. But f double dash x is equal to 0 for points of inflection. What we do, points of inflection purpose, we do the f double dash x is equal to 0. Actually f double dash x is equal to 2 came here. So particular value not coming here. That's why this function not having points of inflection. No points of inflection. If double dash x is equal to 0, that means 2 is equal to 0 is not possible, not exist. That's why there is no points of inflection. It is our points of inflection. Points of inflection meaning already told you, any function changes the symbols. So here to here negative, here to here positive. This is the one point of inflection. Here to here it is the positive. Here to sign change. Here plus, here minus. Here minus to plus. This is the one point of inflection. This is the one point of inflection. Point of inflection over. Next, asymptotes. This function having asymptotes or not. For the asymptotes, what I told you previously, if x tends to a, then y tends to infinity, then x is equal to a is the vertical asymptote. If y tends to a, then x tends to infinity, then y is equal to a is the horizontal asymptote. Like that. In the function f of x here, we see if x tends to infinity, then y it is also tends to infinity. So no value here, particular value. Both are infinity. So x or y any value not coming. That's why here no vertical asymptote. If y tends to any value, if y tends to infinity, suppose x tends to also infinity coming. So no particular value for x and y. There is no asymptotes. For this function, no asymptotes. After this, next concavity. Concavity means that second derivative positive or negative. We check that. In this function, f dash x how much? 2x minus 1. F double dash x is equal to 2 only. This is positive. This is positive. No x values here. This second derivative not depending on the x values. So this is the positive. So critical point where f double dash of 1 by 2 is also 2. So it is the positive. That's why concave upward. Here concave upward only. Upward. In the real line. Upward only concavity. Now come to the graph. How we sketch the graph? First, here x is equal to 1 by 2 is the one critical point. We getting critical point. And the intercepts what coming? At x is equal to 3 and minus 2. These are the intercepts. And y intercept what? Minus 6. Intercept, these are the x intercepts. Minus 6 is the y intercept. We draw the graph. Sketching the graph. X and y here are same. So 3 were somewhere here, 3 point. 3 comma 0, that means minus 2 some here, minus 2. Minus 2 comma 0 point here. Minus 6, the y value minus 6, suppose minus 6 here. Minus 6. So this minus 6 is the y interceptor, 3 is the x interceptor, and minus 2 also x interceptor. So that curve passes through these points. Before going to that critical point where 1 by 2. This is the critical point 1 by 2. At critical point 1 by 2, that value how much came previously? Minus 25 by 4 coming. Minus 25 by 4. That means how much this value? Approximately minus 6.1 something coming. So above minus 6. So some little value here. This is the minus 6. This is the minus 25 by 4. This value. So that's why this is also this is the 1 point, this is the another point, this is the 1 point, this is also 1 point. So critical point is lost minus 25 by 4. We start from here. Okay, concave, this is upward. Concavity, upward direction. Upward direction. So this minus 2 means minus 2 comma 0. This is 3 comma 0. This is 0 comma minus 6 points. This local minima minus 25 by 4 is the local minima. That means local extrema. Local extrema means only here local minima have it. So anyhow, this is the sketching of the curve for the given function. Next 7.70, sketch the curve y is equal to f of x is equal to x cube minus 6x minus 9 curve given. For this curve, first what we find the domain and range of the function. Number 1, domain and its range. Before going to this, factorization is compulsory. How we find the factorization for the checking method? x is equal to 1 put in this, f of x what coming 1 minus 6 minus 9, it is not equal to 0. X is equal to 2, f of 2, that is 2 cube 8 minus 12 minus 9, it is also not equal to 0. At x is equal to 3, f of 3, 3 cube 27 minus 3 into 6 18 minus 9. So this is minus 27 plus 27 is equal to 0. So x is equal to 3 is the factor. At x is equal to 3, this equation satisfied. That's why this is the cubic equation, another quadratic equation. How we find? By synthetic method. By synthetic method, 3 put here. So here remaining coefficient x cube coefficient 1, x square coefficient 0, x coefficient minus 6 and minus 9. Put 0 here, 1 plus 0, 1, 3 into 1, 3, 3 into 3, 9, minus 3 coming, 3 into minus 3, minus 9. Here plus 3, here plus 9. So 0 coming. So factors x minus 3 into, this is x square plus 3x plus 3. This is the function. So here f of x is equal to x cube minus 6x minus 9, otherwise x minus 3 into x square plus 3x plus 3. So for x values any, check at x is equal to 0, at x is equal to 0, then f of x what coming? Minus 3 and 0, 0 minus 3 plus 3, 9 coming. F of 1 at x is equal to 1, what coming? F of 1, 1 minus 3 minus 2, here 1, 3, 3, 6, 7, minus 14 coming. At x is equal to minus 1, f of minus 1 is equal to minus 1, minus 1 in this or in this, anyone, minus 1, here plus 6, minus 9. So minus 10 plus 6, minus 4 coming. So at any x values, for f of x, some values came. That's why x belongs to R. So this is the domain. X domain belongs to R. So its range also, some values coming, minus infinity, infinity coming, that y also belongs to R. This is the range. So finally, domain and range is the x belongs to R, y belongs to R. Next, the intercepts of the curves. Intercepts of the curves. For this, f of x is equal to x minus 3 and x square plus 3x plus 3. So here this function same. That's why put x is equal to 0. Then f of x is the y is equal to what? At x is equal to 0, this is minus 3, this is 0, this is 0 plus 3. So it is the minus 9. Once again we check x is equal to 0. Minus 3, 0, 0 plus 3. Minus 3 into plus 3, minus 9. So intercept, one intercept to 0, comma, minus 9. Put y is equal to 0. Then x minus 3 into x square plus 3x plus 3 is equal to 0. This value is equal to f of x, y is equal to 0 here. So in this x minus 3 is equal to 0, x square plus 3x plus 3 is equal to 0. So x is equal to 3, here x imaginary number. Why? Because it's discriminant b square 9 minus 4ac minus 12. It is negative coming. That's why here x values imaginary numbers. So this factorization is not coming. That's why there is no real numbers. Only x is equal to 3 is the intercept, that what coming point 3 comma 0. This is the another intercept. Next. So anyhow, intercepts of the curves 0 comma minus 9 and 3 comma 0. 3 comma 0 and 0 comma minus 9. After this, critical points. Next, critical points. Critical points. What are the critical points? What is the process? F dash x is equal to 0. Then x values are the critical points. So f of x is the x cube minus 6x minus 9. F dash x is equal to 3x square minus 6 minus 9 quotient 0. So for critical points, f dash x is equal to 0. Then 3x square minus 6 is equal to 0. X square is equal to 6. 3x square is equal to 6. X square is equal to 2. Then x is equal to plus or minus root 2. So plus or minus root 2 are the critical points. Critical points are x is equal to plus root 2 and x is equal to minus root 2. Okay, these are the critical points. Next. After that, local extrema of the function. Local extrema. Local minima and local maxima, that means. So how we find the local maxima and local minima? So given function, local extrema. So here second derivative compulsory for the local maxima and minima. F of x is equal to x cube minus 6x minus 9. F dash x is equal to 3x square minus 6. Second derivative f double dash x is equal to 3 into 2, 6x minus 0. Only 6x coming. So at x, critical points plus root 2 port. This is 6 root 2 greater than 0. Yet x is equal to root 2, f has minimum. F has minimum. At x is equal to root 2, f has minimum. F double dash of minus root 2. So this is minus 6 root 2 coming, less than 0. At x is equal to minus root 2, f has maximum. That values, that is what we substitute the root 2 in the given function. F of root 2 value. That what root 2 cube minus 6 into root 2 minus 9. So this value 2 root 2 and minus 6 root 2 minus 9. So this total value minus 8 root 2 minus 9. Okay, correct? Root 2 cube is the 2 root 2 minus 6 root 2 minus 9. Okay, plus 2 root 2 minus 6 root 2 minus 9. So here minus here plus minus 4 root 2. So this value approximately how much? Root 2 value 1.414 into 4. 4 4 16, 4 1 4 5. Here also 5 6 and 16 5.656 at root 2 into this is minus after minus 9 this add minus 14.656. So this value approximately minus 14.656 approximately, not accurately. After that f of minus root 2. So minus root 2 whole cube minus 2 root 2. Here plus 6 root 2. Here substitute x cube is the minus 2 whole cube minus 2 root 2 coming, minus into minus plus 6 into root 2 minus 9. So here 4 root 2 minus 9, 4 root 2 minus 9. So this value, 4 root 2 value how much? 4 root 2 5.656 minus 9. Minus 9 means 0, 0, 9.00 5.656. So here 4, 8 minus 5, 3. So minus 3.4 like that coming, minus 3.444 like this coming. So local minimum value is the minus 14 minus 656. Local maximum value is the minus 3.44. Okay. So this is one is minus 4 root 2 minus 9 and 4 root 2 minus 9 another value. So here minimum, here maximum. Okay. Next is the extrema over points of inflection. Now points of inflection. Next, points of inflection. What we find points of inflection? Second derivative is equal to 0. Fx is equal to f dash x is equal to what? 3x square minus 6, f double dash x 6x only. So this value, if x less than 0, f double dash x less than 0 coming, sign changed. F double dash x 6x, x greater than 0, f double dash x greater than 0. So x negative values, then concavity downward and x positive values concavity upward. So points of inflection purpose, f double dash x is equal to 0, 6x is equal to 0, then x is equal to 0. X is equal to 0 is the points of inflection. Points of inflection. Okay, at x is equal to 0, points of inflection. So at x is equal to 0, y value how much? At x is equal to 0, then y value how much? Y is equal to minus 9. So point of inflection is the point that point of inflection point 0.0 comma minus 9, and then 0 comma minus 9. This is the points of inflection. Concavity also defined already. Concavity. If negative value is given, that negative coming downward, if positive is that curve upward. So that curve x-axis, y-axis, origin. So one point 3, 0. This is the intercept 3, 0, and 0, minus 9. This is 3, 0, and here suppose 0, minus 9. This is the another intercept. After that, the curve at root 2 concavity upward. Root 2 means 1.414. Here root 2. Here minus root 2. So critical point where critical point root 2 and minus root 2. So these are the critical points. at root 2 value, at root 2, how much coming? Minus 14. This point is the minus 14, means minus 4 root 2 and minus 9. This y value minus 4 root 2 minus 9. No bracket. This is the y value. This is the x value root 2. So root 2, otherwise we written as point form, root 2 comma minus 4 root 2 minus 9. This is the critical point. After that, here to minus root 2 value 4 root 2 minus 9. This is approximately 5 point how much minus root 2, 4 root 2 minus 9, minus 5.6 or something, minus 5.6 here, minus 9 here. This point what, 4 root 2 minus 9 and 0, no, minus root 2. This is the critical point. This is also critical point. So what about the graph? What about the graph? We join this. This is also one point. Yes, this is the one critical point, this is the another critical point. And negative wall is concavity downward. It is the concavity downward. Here to here, this is the concavity upward. Where to where? Concavity upward, x positive walls, here to here. So this is the concavity upward. This is from here to here, concavity downward. Okay, this is the function f of x is equal to x cube minus 6x minus 9. Okay, everything is